Hello all my JavaScript friends, this is TheVirtuoid, aka Mike Smith, and this is our snake game. Well, we've gotten through all the preliminaries, now we're getting to the three big videos. The UI, the input, and the game itself. Today we're going to take a look at the input. Now the whole idea here is that the game will allow you to specify whatever input parameters you wish to have and whatever output parameters you wish to have. Doesn't matter what it looks like, doesn't matter where the data comes from. All it cares about is events. And events will come from these input devices and be sent out to the output devices to be able to give you the snake that you want. So in this particular case, the ones that we do have available right now are our keyboard inputs and our HTML inputs, which you'll see in a video, probably 2 videos from now. This video, we're going to take a look at the input section. Now, basically, the input section, as it shows you here on the screen here, will allow you to select, in this case, the keyboard, either the WASD keys or the arrow keys, game controller, VR set, or whatever inputs we happen to use at some of the later point in time. Doesn't really matter. We can just put any input we want to in there, and we'll show you how that gets done. So without further ado, let's go ahead and take a look at some code. Now in the code here, it's very, very simple. This happens to be the JavaScript that launches the second part of the game that actually shows the snake itself. And the idea here is basically I will create a new input. And within that particular input, we will then add that input. Let me go down here. There we go. We'll add that input to the game. And within the input, we're going to be referencing a device reference, a vector reference, and device data. And those 3 pieces of data are very important. The device reference will basically tell us which device we are using. In this case, it's going to be a keyboard device. The vector reference is going to tell us which kind of vector reference we're going to use. Now, this happens to be the HTML version of the snake, so we are hard-coded ourselves to a vector 2D. Right now, we're also hard-coded ourselves to a keyboard. That will change, obviously, as we start implementing the game controllers or the VR sets or whatever else we could use on the HTML. But for right now, we're just using the keyboard, so we have hard-coded ourselves for a keyboard. And then within the keyboard itself, depending upon what we have selected on the previous screen, we're either able to do the keyboard WASD keys or the keyboard arrow keys, and we'll show you how those are defined here shortly. But that's the whole key here, is that by defining a particular input, giving it a reference to a device, a reference to a vector, and device data, we can talk to anything that gets put into the system. So if I have a game controller, this device reference might go to the game controller. If I had a VR set, it might be a VR set. If I had some sort of, pupil detection device that reads where your eyes are going, then yeah, that will be there too. But the whole idea is that when we get to the game is going to add this particular input. And this input is going to have nothing but different events that will go out to the game saying, hey, go up, go left, go down, go right, fire button, do whatever. Whatever inputs we put into the input itself will get output to the game as events. So all the game has to worry about is that I've got certain events that I am expecting to occur. This is what will come from the input. It doesn't care what input it's going to have. And that's really the beauty of how this works. And the UI works the same way, but the beauty of this is that it doesn't know what device is connected. All it knows is I've got certain events that I'm expecting from the device. So the idea here is that our input is going to always output the same devices. So let's take a look at some code. Output the same events. So let's take a look at some code. And the input itself is very, very simple. I'm the constructor. Of course, we're needing to get a device reference, a vector reference, no big deal. ID, dispose of, no big deal. On an input, basically, with the particular input in this particular case, we're going to either have a change of direction. Some change of direction has occurred here. We're going to have a pause. We're going to do a resume. We're going to do an exit. These are the 4 different events that I expect to occur from any device that is connected to this input. So the input is the one that says, okay, what device am I using? And I'm going to translate all of those inputs and send them back over to the game. And we're only going to accept 4 inputs for now. That will change later on as we start, for instance, VR sets and things like that. That may actually change. But we're going to have a device direction change, we've changed directions somehow. Pause, resume, and exit. And then we will take actions based upon that. So, for example, if there is a change in directions, we're going to admit it back up to the game. Now, as you can tell, that right now this is just a simple pass-through, but this will allow me that if devices do certain really funky things, this will allow me to be able to intercept those devices and normalize any events that come from the devices, so that we send the exact same kind of events. Now, it just so happens for keyboard events that we're using right now, everything's just a simple little pass-through. For instance, on a change of direction, I'm going to emit this information as a change of direction back up to the game, but I'm also going to pass it what the ID of the device was and the direction that we're going, so that when the game receives the input, the event, and we'll see the game events come in a couple of videos from now, it will know that, hey, it came from this particular device and it had this particular direction. I need to do whatever I need to get done. Change speed is something I wanted to be able to do later on, but right now there is no change speed, but that's for later on. That's why it says this is for future enhancement. Game pause, all I'm going to do is pass it the ID. Game exit, pass it the ID. Game resume, and pass it the ID. And that's it. I don't do anything else. For right now, all the input does is, okay, I'm going to get an event from my device. I'm going to do whatever normalization I have to do with it, and I'm going to send it onto the game. And so, like I said, right now we're just sending 4 different events, and that's it. As we get into more complicated input controls, this will change. But for right now, since this is just a keyboard that we've got implemented right at this time, this is all we're going to need, and that's it. So the key here for the input is that it will take devices, and all that is passed to us here in the device reference. And as you can tell here, we actually initiate the device at this point in line 25. But it takes that device reference and expects events to come in from those devices. It will normalize those events and then pass it on to the game. This will allow the game to be able to not care what device is connected up to it whatsoever. All it knows is, I've got these 4 events that I expect to come from an input. I will process them as it goes along. So that's all there is to the input. There is nothing else. The key here is the device. The device is going to be the class that contains all the information we need for the device. So let's take a look at the device itself. We're on the left-hand side here. And the device is actually very, very simple. This is a base class. And the base class for the device basically says, if I'm going to create a keyboard class, or if I'm going to create a game controller class, or if I'm going to create a VR set class, they will all extend the device class. What's important for them is they're going to need some sort of vector reference. And that's extraordinarily important because the devices themselves don't know what kind of output we're going to be looking at. So when we work with the games are going to have to say, okay, I know I'm going to be on an HTML. Well, let's go back to HTML here. I know I'm going to be on an HTML screen, so it's a 2D screen. So my vector reference is going to be vector 2D. And that's important for the device because the device is, when it sends out its events, it's going to need to know whether, hey, this particular event is going to be like an up, down, left, right, like you do have a keyboard, or it's going to be some sort of nuance between all the different 360-degree cardinal directions like you would get with a game controller. So it's very important that the device knows what vector, but it cannot assume a 2D vector or a 3D vector or a 4D vector or 16D vector. It can't assume that. It has to assume I've just got a vector. And that's really all there is to the device. There really is not a whole lot of device there. The key is how it's implemented. And in this particular case, right now, we just have the keyboard implemented. And the keyboard implemented we got on the left-hand side here is also relative, and I emphasize the word, it's relatively simple. The keyboard here is a driver that now specifically developed just for a keyboard. So I'm taking a look at my keyboard here. I basically have digital keys, analog keys that says up, down, left, or right, depending upon how I've got it mapped out here. But I do know I'm going to have to map out 4 events because the keyboards are always the inputs are always expecting to have at least 4 events. A change in direction event, in fact, let's go back there. It's going to definitely need a change in direction event. It's going to need a game pause event. It's going to need a game resume event, and it's going to need a game exit event. That all comes from a device. So it's going to be the device's responsibility to make sure that all 4 of these are taken care of. So let's take a look and see how the keyboard has done it. Again, I'm having to pass a vector reference and a layout reference and an input reference. And the layout reference is something that's very important for the keyboard here, because I want in this particular case to be able to use WASD keys or the arrow keys. And so what you'll notice inside the snake HTML here, I am passing it, depending upon whether I want a keyboard WASD or keyboard arrow, I'm passing it a layout of WASD or layout arrow. And we'll show the layouts here in just a second. But the keyboard here is going to want to have a layout, an input, and a reference. And the input is basically saying, what's my input that I need to send this information off to, because the device is going to send information to the input. It's not going to send it to the game. It's going to send it to the input and let the input do whatever it has to do with it. And that's all there is here. So the key here is that this is our binding. And if the driver happens to be a keyboard driver browser, we sit there and do an add event listener. Why have we done it this way? Well, the reason we've done this driver browser here is that the keyboard may have a non-browser input, for instance, Node or Deno or something like that. We never know. So therefore, we need to be able to have an add event listener. So if I happen to have, using Node or Deno on a terminal, which I do actually want to be able to implement at one point, I'm going to have a different event listener for the keyboard. Right now, all I got is the browser. That will come a little bit later on. Okay, that's just a bunch of getters. Then we have the process keystroke, because this is the big thing here, is the add event listener, that we had some sort of event listener here. When we do the process keystroke, we get that key, we get the key of the keystroke, and then we get the layout, and then we get the key mapping. Now, what's the layout all about? Well, if we go to the keyboard layout, it's the if we go to the keyboard layout itself, it's just a simple little singleton type implementation where everything is static. And the idea here is that we basically map what the keys I'm going to use for WASD. So in this case, if I hit a key A, that's going to give me a vector left and a change in direction. I'm going to give it, in this particular case, I've defined a keyboard layout as basically returning 2 different properties, an action and direction, so that when a keyboard is hit, when we actually hit a key, it's going to get that particular key mapping from the code. It's going to get that particular key mapping based upon the code. And that code is going to be key A, key D, key S, W, P, R, and escape. So in the particular case, in this particular case, for the keyboard, I'm expecting 2 different arguments to come in from the keyboard mapping. It's going to be our action, and that action is going to be, is this going to be a change in direction, a pause, resume, or exit? So if you notice, these match exactly what I expect on the input. Direction, pause, resume, exit. I've got to have those 4 pieces of information coming from the layouts. And sure enough, this is what the layout's going to give me. Here's my 4 changes in direction. Here's my game pause, my resume, and my exit. We give the action. What is the direction we're going to give? The direction is going to be left, right, down, or up. Very, very easy. Very, very simple. But notice it's based upon the vector. It's not vector 2D, vector 3D, vector 4D. It's based upon the vector. Because each of the 2Ds, the 3Ds, and 4Ds each have a left, right, up, and down already defined. And that's all I'm going to be passing within the keyboard. So, if we do have, a game controller or something, it's not going to be left, right, up, or down. It's going to be whatever degrees I happen to have the stick pointed to. It doesn't matter. Well, what about for the pause, the resume, and the exit? Well, those are all just nulls because there's no direction. And that's for WSD. Well, what if I wanted arrow keys? Well, arrow left, arrow right, arrow down, arrow up. This is the exact same thing I had up here at the WASD. I've just now defined 4 other ones. So if I wanted to find for some strange reason UHJK, and do that, or if I wanted to be able to have the letter M for pausing, or the letter or a Shift Alt Z for something like for escape or something like that, I can do that based upon these particular mappings. I would just need to make sure that whatever I use here is the keystroke that I'm looking for, and that's pretty much it on the layouts. So the layouts is what defines the different mappings that I want to use. In this case, the WASD keys or the arrow keys. And here, as you can tell, I can define any sets of keys for anything. And if I happen at a later point in time to be able to need something more than just change direction, pause, resume, and exit, I don't know what, but if I happen to do that, all I have to do is go into keyboard layout here and just map those keys, and everything else is taken care of me, because keyboard doesn't care what keys has been clicked. All it cares about is that I've got an actual key mapping. And if there's a key mapping, we send the key mapping to an on input, which is what handles on input. There it is, which is what handles the different events that occur. And that's pretty much it for the input. It's actually very simple in what it does. So in recap, the idea is that the snake game only takes a look at the input. It doesn't care about anything else. It doesn't care about what device is connected to it. The input does care what device is connected to it. Actually, I'm taking it back. The input doesn't care what device, but it does care that it has particular, at least it expects a particular set of events to come in from the device. And that's all it cares about. The device then itself is responsible for sending out that particular event. And in this particular case, it's defined inside the keyboard layout. It could be defined, if I did a game control, it'd be defined somewhere else. But that's basically it. This allows me to obfuscate whatever input device I need for the game. So all I have to do is to have a new device connected up to the input, and make sure that it gives me the correct data that I need. So for an HTML game, if I was hooking up a controller, what will happen is that the controller device would send the position of the stick, and that won't be a solid left, right, up, or down, but it would be the responsibility of the input possibly to be able to ensure that it's a left, right, up, or down. I'm not sure exactly how that's going to work. We'll find that out next year, because next year is when we're going to start adding in all of the different inputs and all of the different UIs and showing how everything gets plugged in. And so that's pretty much all there is to the input. Next week, we'll be taking a look at the UI portion of the game.
Thanks for watching. Subscribe to this channel to view more videos. Click on the like button on this video and visit us at virtuoid.com. Also, support us on Patreon, where you can get access to member-only videos. Links are down below. Again, thank you very much for watching, and keep on coding.